Hey guys, here we are, Chapter 18, Section 2. We're going to talk about outdoor air pollution. So, what leads to it? Why is it there? All that stuff. Well, first off, when we're talking about outdoor air pollution. We'll actually talk about indoor air pollution later. Just chill. There are both natural and human sources of it, as with pretty much everything. In environmental science, we tend to focus on the human sources of it, but just to make sure that we address both occur. Now, air pollution, just the presence of chemicals in the atmosphere, right? Anything that's degrading the air quality till it's causing harm, either something living in it or from it, like you and I have to breathe the air around us. Now, when the concentrations get high enough to harm organisms, ecosystem, and even human-made materials or alter the climate, this is when we really kind of stand up and take notice, right? So we're really talking about air pollution when it's causing harmful changes. Now, natural sources of it. Let's kind of address those, get them out of the way, if you will. They're just wind-blown dust. Air pollution is nothing but stuff in the air. Well, this can be dust. If you're inhaling too much dirt and dust, or it's a problem. It cause you whatever, wildfires. Just a fire burning. We've all been around the campfire or a fire pit somewhere and the smoke blows in your direction and you can't see. Smoke. So this is a natural occurrence. Lightning strike starts up a fire, wildfire, putting smoke, hydrocarbons up into the air. There are some volatile organic compounds, VOCs, that actually get released by plants. Plant matters release, to a certain degree, noxious chemicals, and if you're close to them, they can be hard to breathe and cause irritation, etc. And some people are allergic to certain things, what have you. All of these are just natural sources, not to mention things like volcanoes, right? Volcano erupts, lots of sulfur dioxides into the air, ash, the whole 9 yards. Natural sources of it. Human sources, for the most part, is coming from industrialized and urban areas, where we have a lot of cars and factories, burning various fossil fuels, by and large. Not the only reason, but fossil fuels are the biggest part. We have both stationary sources, like a power plant or an industrial facility, a steel mill, where they're having to burn coal or something to create the heat, to create the power, industrial. And then we have mobile sources. For the most part, we're talking about our vehicles, right? Cars, trucks, tractors, what have you, but they're going around and spewing out the pollution wherever they go. So we get a little bit of both, from the pictures it talks about one or the other. They're all putting things, chemicals by and large, up into the environment, making it hard to breathe or causing those other problems, whether it's affecting buildings or the climate, what have you. When we talk about air pollution, we're going to talk about in really broad categories. We have primary pollutants. These are things that are emitted directly into the air. We know when we burn coal, we're going to release some sulfur into the air in the form of sulfur dioxides. We know when we burn oil, we're going to release some nitric oxides into the air. These are primary pollutants. We know it's occurring. I burn a stick or I'm out at a campfire, I know I'm going to release some hydrocarbons, some soot, into the atmosphere. I can see it in the smoke, right? These are primary pollutants. We know we're putting them into the atmosphere. Secondary pollutants, these are formed from chemical reactions of the primary pollutants. The primary pollutants go up into the air, like we've talked about, sulfur dioxides, they go into the air, they interact with the water, H2O, and form sulfuric acid, H2SO4. It's a secondary pollutant. We knew about the one, but sulfur goes up and acid rain comes down. Primary pollutants, we know they're going in. Secondary pollutants, a chemical reaction occurs in the atmosphere when two compounds form together to create a new substance. And whether it's carbonic acid, nitric acid, sulfuric acid, there are other things that occur as well as ozone, but we'll get to those in a bit. Now there's a science focus in the chapter Chapter 18.1, it talks about atmospheric brown clouds. Now, atmospheric brown clouds have been found largely over the Asian continents, India specifically and China. It's not the only occurrences, but that's where we've tracked more of these. A lot of these come from what we just call low-tech pollution. People are still cooking by burning something. They're burning corn stalks, they're burning wood, they're burning cow dung in order to cook their food or heat the area. And these low-tech pollutions, smoke, is going up into the atmosphere. Now, it's just smoke, ash, soot, and even particles of dust. I talked about when we lived in Nepal, it was an ancient lake bed, but as we drive across it, that really fine powdery dirt just gets flown up into the atmosphere, and this makes it all the way up into the clouds, and we get this atmospheric brown cloud. We've tracked some of these things. They're miles thick. I remember flying into India and looking out, and you could see this layer of brown cloud way up over the cities, but it's just this brown cloud hovering over the whole thing. It's caused by wind stirring up the dust, erosion coming off, and fire. A lot of these are just low-tech local fires of people cooking. We find them all throughout Asia, even into the Western Pacific as they get blown across. Now, this pollution travels from areas into remote areas. These brown clouds exist for really large areas and drift over entire continents. So they're being created mainly in the industrial areas, but they're affecting rural areas because, once again, the atmosphere causes them to travel. So we don't always just have pollution where it's created. Sometimes it drifts and gets carried somewhere else based into the clouds. These brown atmospheric clouds are actually carrying debris over across into the Himalayas, and some of this dust is then falling out and soot landing on the glaciers, darkening them up, causing them to melt quicker. Once again, dark things absorb more heat, they're not reflecting as much light, and their albedo is greater, therefore they are melting quicker, and we wind up into a positive feedback loop. The dust falls on, it's black, it warms, it melts, less ice, therefore more heat, etc., etc. But we've tracked these brown clouds all through the area and realizing it's something that is affecting our climate, and it comes from human pollution, largely low tech. But there's so many people burning and stirring up the dust that it's causing a large regional scale problem. Let's talk about some of our major outdoor air pollutants. Well, we're going to talk about carbon oxides, nitrogen oxides, and sulfur oxides. Now, carbon oxides, for the most part, we're talking about carbon monoxide, carbon dioxide. Anytime you burn something, it releases carbon dioxide. We have to have carbon, something to burn, and we have to have oxygen with it. Carbon and oxygen form together to form CO2. If I don't have enough oxygen present, it forms CO, carbon monoxide. So in an imperfect burn, I get carbon monoxide. But anytime we burn anything, we release these into the atmosphere. We also release nitrogen oxides. Now, by and large, nitrogen oxides are coming from burning oil, and we're going to talk about sulfur dioxides in a bit. They come from burning coal. Now, it's not exactly one-to-one. It's not like oil only produces nitric oxide and coal only releases sulfur. They both actually release both. The coal releases more sulfur dioxides than nitric, and oil releases more nitrous oxides than sulfuric oxides. But just understand they come from burning fossil fuels. Carbon oxides come from burning anything, trees, it doesn't matter. But when we get to our fossil fuels, nitrogen oxides are burning oil, gasoline, petrol, right? Diesel fuel. We burn it and it creates the nitric oxides. Can be nitrogen dioxide, nitric oxide, nitrous oxide. All of these come from burning oil. And they lead to acid deposition. Nitric oxides in the air form with H2O to form nitric acid, falls out of the sky, and also nitric oxides, we're going to look at a little later, play a role in photochemical smog. we talk about smog. We have industrial smog and photochemical smog. Taking us to sulfur dioxides. Sulfur dioxides largely released from burning coal. So our power plants, industrial steel mills, all sorts of industry, burning coal releases sulfur dioxides into the air. Sulfur dioxides reduce visibility. It tends to make things a little bit brown and yellowish in color. They aggravate breathing problems, as does nitric oxides, but trying to breathe. And they also lead to the formation of sulfuric acid, SO3, H2O, H2SO4, sulfuric acid. Now, we also just get particulate matter, right? Stuff in the air, suspended particulate matter, particulates. This can be dust, right? It's going to be pollen, anything that's in the air. These particles cause problems for our breathing. Once again, when I lived in Nepal, a lot of the pollution was just particulate matter. Pollen and dust thrown up into the air, but you're still breathing it, getting in your face and in your lungs, causing a problem. And we get ozone. Now, ozone is O3. In the stratosphere, ozone's a good thing. Down here in the troposphere, where you and I are, ozone's a bad thing. It causes coughing, causes breathing problems, and once again, it's part of this photochemical smog, which we're going to get to in a little bit. Another one of the major outdoor air pollutants are VOCs, volatile organic compounds. Well, oil is actually a volatile organic compound, right? It's organic, came from living animals, and it burns. Alcohol comes from plant, but we can light it and it burns, right? So volatile organic compounds. Methane, natural gas, is a volatile organic compound. Benzene, dry cleaning fluids, any of our gasolines, byproducts of gasolines, benzene, toluene, styrene, things like mineral spirits, paints, anything that on the label it says, use in a well-ventilated space. They tend to have strong smells, but once again, they will combust, they will burn. Volatile organic compounds. The more of these we have in the air, the more problems it causes with breathing. The chart I'm throwing up back here is just showing some of the pollutants and then chemical reactions that can form from these, primary versus secondary, right? So carbon monoxide, we talked about. You get two carbons and an O2 molecule, and it will form two COs, carbon monoxide. Once again, it's an imperfect burn. If there's enough oxygen, we tend to get the next one, carbon dioxide. C plus O2 yields CO2. In a good burn, I have twice as much oxygen as carbon, and then I get CO2. If I don't have enough oxygen in the burn, it produces carbon dioxide. It's an imperfect combustion reaction, if you will. Nitric oxides. Now with nitric oxides, we'll look at a couple. Nitric oxide. So N2 plus O2 yields 2NO. I get 2NO, nitric oxide molecules. Nitrogen dioxide O2, NO2, nitrogen dioxide, is when I have nitrogen oxide, and then that mixes with a oxygen O2, then we get nitrogen dioxide. We can also get nitrous oxide, N2O, but all of these nitric oxides, if you will, come from largely burning of oil, and then we have our sulfur dioxides. Mainly when we burn coal, also happens from volcanic reactions, a little bit from burning of regular trees because sulfur is part of it, but I digress. So sulfur plus O2 yields SO2. SO2s go up, form more oxygen, we can form SO3s, but then H2SO4 is our sulfuric acid. But these are just some of the ones that we make. And when we talk about our acid rain, like if you look at the picture back here, this is a 60-year difference in a statue. One, you can see the facial features, etc., the folds, and then the next one, everything's just kind of fuzzy and blurry. This is the effect of acid rain. It just slowly erodes, and especially with our cement, because it's largely made from limestone, calcium carbonate reacts with acids and it dissolves away. Now, a case study. we talk about lead. Lead is a highly toxic pollutant. Now, we find lead in air, water, soil, plants, animals. We find it everywhere. It's an element, right? PB, lead. It's a unique element. It can't break down any further. And it's just out there. We find it in the environment, part of kind of the rock cycle. It's a mineral, right? Well, since it doesn't break down in the environment, it's already just lead, it impacts human health. And it's one of these things that we can get biomagnification from. The more you interact with it, the worse it can be for our health. Now, children tend to be most vulnerable. Once again, they're smaller, they're breathing a large amount or taking things in, and kids tend to stick everything in their mouths. Though lead tends to have a greater effect on children. In enough quantities, it can cause death, but it also has brain damage, it can drop down the IQ, any small amounts. Now, lead exposure for adults and children have gone way down in the United States because we've basically banned lead in paint and a lot of the things that we used to have it in. We used to use lead soldier in sinks and it could get into the water supply. We used to use lead in paints. We used to have lead in gasoline, and that was banned in the late 70s, early 80s, or it began to phase out. I think by 86, all lead gasoline was gone in the United States. But those quantities existed and people breathed it in. And still today in other parts of the world, it's lead gasoline is not necessarily banned, and lead paint is not banned. And also lead is in a lot of e-waste, like computers that are thrown out. Well, people are pulling the parts out to recycle it, and a lot of people do get exposed to lead poisoning in this way. Now, lead poisoning, what do we do, right? Well, here are some of the solutions. We need to replace the lead pipe that was in plumbing. Some older homes, especially homes that were built in the 70s, may still have lead piping in them. And once again, a lot of times this is in our older homes and in the poorer areas and neighborhoods, and they're not as well equipped to go replace their lead piping. But it's a need that we need to do. We need to phase out leaded gasoline worldwide, because anywhere that it's burned, it releases it into the atmosphere, that it settles down into the water, plants drink it, and we get it in. Phase out waste incineration. When we're burning it, well, anytime we burn lead, it once again vaporizes it, it's back into the atmosphere. Ban the use of lead in computers and TV monitors. We have other substances we can use. It's not needed, but it was cheap and it worked, so it was used. But we simply need to ban it. We realize the toxicity level is just too high to have it in the air. So many people on the planet now, it just causes problems. You need to wash your fresh fruits and vegetables. Once again, it's in the air, things land on it. We want to try and get rid of what we can. And then just try and, that's kind of prevention. What can we do to prevent it? That's the prevention. And then control. What do we move that's there? Well, remove leaded paints from anything. Older home, once again, if you live in a home that's built in the 70s, it has, you want to just not paint over, but actually get rid of a lot of the paints. We need to reduce the lead emissions in anything that it's included in. Once again, phasing it out as best of all possible. Remove it from the TV sets, any of the electronics. We have other materials that we can use instead of lead. It's not mandatory. Test blood in kids by age 1. We need to find out, are you in an area where you're exposed to it, so we can then identify. But we probably need to have some sort of universal testing of children when they're really young to find out what their blood levels are. And just test for it in places where we serve food. Once again, are the vegetables coming in, are they getting washed properly? When food is getting prepared and served, well, we need to test some of the content to find out. We need to know the content of lead so we can tell it's a problem. It's just something worldwide, it's an issue, we know about it, but we need to do more to address it, if you will. Now, how do we detect these air pollutants and monitor our air quality. And we learned about the atmospheric brown clouds. Well, there's a lot of ways that we do that. Sometimes we can literally use plants as an indicator species. Lichen are some of these. Lichen can be incredibly sensitive to pollution levels. Certain types of lichen can't survive in different types of pollution, and it gives an indication if we have sulfur dioxides, nitrogen dioxides, or whatever. We also run these air quality index, AQI, to determine how safe is it out there, because from day to day, low pressure versus high pressure systems, windy days, still days, it affects our air quality. Once again, even the pollen and the dust that's stirred up makes a difference. So with this, we can track the ground level ozone, we can track the particulates, how much dust or pollen is in the air, how much carbon monoxide, the dioxides, whether it's nitrogen or sulfur. So sometimes we're using drones, using different things to test. In some cities, we just have monitors set up that can determine what the air quality is, all kinds of ways that we deal with it. Now, as promised, we're going to talk about smog. And really, we have two different types. We'll talk about industrial smog and photochemical smog. Now, when we talk about industrial smog, the chemical composition of this is basically sulfur dioxides, which can lead to sulfuric acid and suspended solid particles. All this will be up in the air. The sulfur dioxides go up, then we get little particles of sulfur dioxide, as well as just solid particles like burned carbon, soot in the air. All of this combined together creates what we call smog, and it tends to be this low-lying, heavy layer of pollution, largely coming from the combustion of coal and oil, and these are forming our carbon dioxides, carbon monoxides, also mixing with the sulfur and the nitrogen. All this base together hovers down close to the ground, gravity helps pull it down, and we get our smog. It is most common in industrial and urban areas. And once again, the more industrial the area, the more factories that are burning coal, the greater the chance of getting industrial smog. China, India, and the Ukraine have some of the worst levels of it, kind of the worst offenders, if you will. Areas with really high population, very dense, and not as many controls on their factories producing the pollutants. Burning coal without pulling the pollutants out. In America, our smokestacks have electrostatic precipitators and scrubbers to pull a lot of the pollutants out. All of our cars have catalytic converters in them designed to pull a lot of these pollutants out. Not everywhere in the world has these same precautions in place, and they lead to much higher levels of smog. And unfortunately, this smog can travel. It don't always stay in one area. Beijing's air quality is among some of the worst in the world. Of the most polluted cities in the world, something like 9 of them are in India alone. The population, and they don't have controls on the pollution, get pretty bad. Now the picture back here is just a quick little graphic kind of showing this idea. We're burning coal and oil, so the stacks of coal. We burn anything, we release carbon dioxide. If it's not a pure burn, we also release carbon monoxides. When we burn coal, we're also releasing sulfur oxides and nitrogen oxides. In an industrial area, we're burning all of them. We're burning natural gas, we're burning oil, cars driving around, and we're burning coal, largely in our power plants. But all of these lead to industrial smog. And we have industrial smog largely from all these pollutants being created and sitting in this one area. And we also have what we call photochemical smog. Now, photochemical smog is a little bit different. This is formed under the influence of the sun's UV radiation. Largely, this comes from vehicle emission. Cities with a lot of cars, a lot of vehicle emissions, so we get VOCs, volatile organic compounds, sometimes released from trees, from nature, add into the mix, dry cleaners, all kinds of sources, chemical refineries, gas or oil refinery stations releasing VOCs in the air, and nitrous oxides. It doesn't matter whether NO, N2O, NO2, all of these nitrous oxides. The VOCs, along with the nitrous oxide and heat, Typically this happens in warmer climate areas. LA is our classic example. We see a lot of examples in China, other cities as well. But where it's warm, it tends to be worse. The sunlight comes through, interacts with the nitrous oxides, and creates ozone. So this mix of these VOCs, sulfur oxides, nitrogen oxides, and ozone create a layer of smog that sits and lays down and traps, especially in cities that are like in a valley where it gets much worse. So all of these ground level ozone, the other photochemicals, along with various aldehydes, like formaldehyde, various aldehydes, create this secondary pollutants, and this is where we get our photochemical smog from. It's just this really noxious layer that occurs. Industrial smog, photochemical smog, factors that affect outdoor air pollution. Well, we have some factors that help clear it up, and we have other factors that make it worse. Well, factors that help reduce it. Gravity. Most of these particles in the air, well, gravity pulls them down to the surface. When we lived in Nepal, during the day, the pollution was bad. In the evening, when the cars stopped traveling, a lot of the pollution just settled down because it was being stirred up. Or the factory shut down. We weren't burning and releasing the chemicals, and that smoke settles down. Gravity itself does a lot to help clear it up. Rain and snow. When it rains, it clears out the pollution. As a kid, we used to make snow cream, like ice cream, but out of snow. But my dad had a big rule. We couldn't do it with the first snowfall. We had to wait for the second day of snow, because the first snow cleared out all the pollution. And there was really a lot of truth to that. Snow in the rain helps clear out stuff in the air, so it helps clear our pollution. If you happen to live near the ocean, in Florida, most of us do, the salty sea spray. The salty sea spray out the heavy water, it gathers it and drops it down to the ground. Wind itself will help clear it out. If it's a really windy day, a lot of times it's very clear. Now, if you live near farmland and it's dry, it might stir up dust. So, wind can work a little bit of both ways. And then there are a lot of these natural chemical reactions remove some of the pollutants. Actually, the sulfur dioxides mixing and causing sulfuric acid, well, the sulfuric acid falls out of the sky, taking these sulfates out of the air, which can cause problems with breathing. So there are a lot of just natural things occurring that help decrease it. Well, what are the factors that increase the outdoor air pollution? Well, a lot of urban buildings. If you're in an area with a whole lot of buildings, well, this cuts down on the wind, right? It can't blow and clear things out, so it stays trapped in. Hills and mountains. Areas that have lots of hills and mountains. Kathmandu, Nepal. Here's a quick picture. It's in a valley. Well, surrounded by mountains, so the winds kind of blow over the top, and all the pollution just sits in the valley. California is like this as well. Anywhere where you have mountains on three sides and then the ocean on the other is prone for what we call a temperature inversion, and this tends to make the pollution worse. But once again, hills and valleys, if it's hot, high temperatures tend to lead to worse pollution, VOC emissions, any of these volatile organic compounds. Now, some of these are human created and others are coming from natural sources. Certain plants and trees release them. Then we get what we call the grasshopper effect. A grasshopper takes off here and it lands way over there. We're producing pollution over here, but the winds carry it and it falls over here. And this grasshopper effect that can increase our outdoor air pollution. It should be nice and clean here because they're not doing anything, but it's blowing downwind. Grasshopper effect. And then we get the temperature inversion. If you take a look at the picture back here, it's trying to highlight what a temperature inversion is. Typically in an area with mountains on sides or all around, either way, you get this valley. When you're in the valley, if you produce a lot of these photochemical smog or industrial smog, it gathers. The wind can't blow it or carry it away, and a lot of these particles are kind of heavy and they sit down. Well, in a temperature inversion, what happens is normally hot air rises. So the smoke is hot, it rises, it mixes up with the air and it blows away and it stays nice and clear. Well, in a temperature inversion, I get a layer of warm air up here. So this warm air is rising, but it hits air up here that's warmer, and it has nowhere to go, so it begins to fill up below. One of our labs we do kind of highlights this with the smoke under the beaker. The ceiling of the beaker is like the temperature inversion layer. The smoke hits it and then it begins to fill up the beaker. This is an inversion layer. In any town or city that's in a valley surrounded by mountains, especially if there's a lot of cars or industry, whenever the temperature inversion occurs, it's a phenomenon. It doesn't happen every day, but on those days, the pollution gets worse and it looks like this. So this is LA on a temperature inversion day. They're not always like this, but some days it can get really bad. Guys, that wraps it up for the air pollution. It was kind of a lot in this one. Come back next time and we will talk about acid deposition, acid rain. Take care. We'll see you next time.